Well, good morning, ladies and gentlemen. My name is Art Benjamin, and I am a mathematician. What that means is I combine my loves of math and magic to do something I call mathemagics. But before I get started, I have a quick question for the audience. By any chance, did anyone happen to bring with them this morning a calculator? Seriously, if you have a calculator with you, raise your hand. Raise your hand. Was your hand go up? Now bring it out. Bring it out. Anybody else? I see one way in the back. You, sir, that's 3. And anybody on this side here? Okay, you over there on the aisle. Would the 4 of you with calculators please bring out your calculators, then join me up on stage, and let's give these volunteers a nice round of applause. That's right. Now, since I haven't had the chance to work with these calculators, I need to make sure that they are all working properly. Would somebody get us started by giving us a 2-digit number, please? How about a 2-digit number? 22. And another 2-digit number, sir? 47. Multiply 22 times 47. Make sure you get 1,034, or the calculators are not working. Do all of you get 1,034? 1,034? No. 594. Let's give 3 of them a nice round of applause there. Would you like to try a more standard calculator just in case? Okay, great. What I'm going to try and do then, I noticed that took some of you a little bit of time to get your answer. That's okay. I'll give you a shortcut for multiplying even faster on the calculator. There's something called the square of a number, which most of you know is taking a number and multiplying it by itself. For instance, 5 squared would be 25. Now, the way we can square on most calculators, let me demonstrate with this one, is by taking the numbers such as 5, hitting times, and then equals, and on most calculators that will give you the square. On some of these ancient RPN calculators, you've got an x squared button on it, will allow you to do the calculation even faster. What I'm going to try and do now is to square in my head 4 2-digit numbers faster than they can do on their calculators, even using the shortcut method. What I'll use is the second row this time. If I get 4 of you, 1, 2, 3, 4, to each yell out a 2-digit number, and if you would square the first number, and if you would square the second, the third, and the fourth, I will try and race you to the answer. Okay, so quickly, a 2-digit number, please. 37 squared, okay. 23 squared, okay. 59 squared, okay. And finally, 93 squared. Would you call out your answers, please? 1369. 529. 3481. Thank you very much. Let me try to take this one step further. I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone I point to call out a 3-digit number. Anyone on our panel verify the answer. Just give some indication if it's right. A 3-digit number, sir, yes? 987. 987 squared is 974,169. Yes? Good. Another 3-digit. Another 3-digit number, sir. 457. 457 squared is 205,849. 205,849. Yes. Okay. Another 3-digit number, sir. 321 is 103,041. 103041. Yes. One more 3-digit number, please. 722 is 500. Ooh, that's a harder one. Is that 513,284? Yes. One more 3-digit number, please. 162 squared is 26,244. Thank you very much. Let me try to take this one step further. I'm going to try to square a 4-digit number this time. Now, you can all take your time on this. I will not beat you to the answer on this one, but I will try to get the answer right. To make this a little bit more random, let's take the 4th row this time. Let's say 1, 2, 3, 4. If each of you would call out a single digit between 0 and 9, that will be the 4-digit number that I'll square. 9, 7, 5, 9758. This will take me a little bit of time, so bear with me. 95 million 218,564. Thank you very much. Now, I would attempt to square a 5-digit number, and I can, but unfortunately, most calculators cannot. 8-digit capacity, don't you hate that? So since we've reached the limits of our calculators, what's that? Does yours go? Does yours go higher?
How many numbers is that?
Yours does? I'll talk to you later. In the meanwhile, let me conclude the first part of my show by doing something a little trickier. Let's take the largest number on the board here, 8649. Would you each enter that on your calculator? And instead of squaring it this time, I want you to take that number and multiply it by any 3-digit number that you want. But don't tell me what you're multiplying by, just multiply it by any random 3-digit number. So you should have as an answer either a 6-digit or probably a 7-digit number. How many digits do you have, 6 or 7? 7, and yours? 7? 7? And uncertain. 7. Is there any possible way that I could know what 7-digit numbers you have? Say no. Good. Then I shall attempt the impossible, or at least the improbable. What I'd like each of you to do is to call out for me any 6 of your 7 digits, any 6 of them, in any order you'd like. 1 digit at a time, I shall try and determine the digit you've left out. So starting with your 7-digit number, Sonny, call out any 6 of them, please.
197040.
Did you leave out the number 6? Good. Okay, that's 1. You have a 7-digit number, call out any 6 of them, please. I think I only heard 5 numbers. 44875. Did you leave out the number 6? Same as she did. Okay, you've got a 7-digit number. Call out any 6 of them loud and clear.
079044.
I think you left out the number 3. That's 3. The odds of me getting all 4 of these right by random guessing would be 1 in 10,000, 10 to the 4th power. Okay, any 6 of them. Really scramble them up this time, please.
263972.
You leave out the number 7. And let's give all 4 of these people a nice round of applause. Thank you very much. Thank you. Thank you. For my next number, while I mentally recharge my batteries, I have one more question for the audience. By any chance, does anybody here happen to know the day of the week that they were born on? If you think you know your birthday, raise your hand. Let's see, starting with, let's start with the gentleman first. Okay, sir, what year was it, first of all? That's why I start with the gentleman first. What year? 1953, and the month? November what? 23rd. Was that a Monday? Yes, good. Somebody else, who else would like to say? I don't have to see as many women's hands. Okay, so how about you? What year? 1949, and the month? October what? 5th, was that a Wednesday? Yes, I'll go way to the back right now. How about you? Yell it out. What year? 1959. 1959, okay, and the month? February what? 6th, was that a Friday? Good. How about the person behind her? What year was it?
1947.
1947, and the month?
May.
May what?
7th.
7th, would that be a Wednesday?
Yes.
Thank you very much. Anybody here who'd like to know the day of the week they were born? We could do it that way. Of course, I could just make up an answer and you wouldn't know. So I come prepared for that. I brought with me a book of calendars. Goes as far back into the past as 1800, because you never know. I didn't mean to look at you, sir. You were just sitting there. Anyway, Chris, you can help me out here if you wouldn't mind. This is the book of calendars, and I'll ask, who was it that wanted to know their birthday? You, sir? Okay. What year was it, first of all?
1966.
66. Turn to the calendar with 1966. And what month?
April.
April what?
17th.
17th. I believe that was a Sunday. Can you confirm, Chris?
Yeah.
Yeah, okay. I'll tell you what, Chris, as long as you have that book in front of you, do me a favor, turn to a year outside of the 1900s, either in the 1800s or way into the 2000s. That'll be a much greater challenge for me. What year, Chris, would you like?
1824.
1824, okay. And what month?
June.
June what?
6th.
6th. Was that a Sunday?
It was.
And it was cloudy. Good. Thank you very much. But I'd like to wrap things up now by alluding to something from earlier in the presentation. There was a gentleman up here who had a 10-digit calculator. Where is he? Would you stand up? 10-digit guy? Okay, well, stand up for me just for a second so I can see where you are. Okay. Oh, okay. You have a 10-digit calculator, sir, as well? Okay. What I'm going to try and do is to square in my head a 5-digit number requiring a 10-digit calculator. But to make my job more interesting for you as well as for me, I'm going to do this problem thinking out loud. So you can actually honestly hear what's going on in my mind while I do a calculation of this size. Now, I have to apologize to our magician friend Leonard Green. I know as a magician we're not supposed to reveal our secrets, but I'm not too afraid that people are going to start doing my show next week, so I think we're okay. So let's see. Let's take a different row of people. Starting with you, I'll get 5 digits. 1, 2, 3, 4. Oh, I did this row already. Let's do the row before you. Starting with you, sir. 1, 2, 3, 4, 5. Call out a single digit. That will be the 5-digit number that I will try to square. Go ahead. 5. 7. 6. 8. 3. 57,683 squared. Yuck. Let me explain to you how I'm going to attempt this problem. I'm going to break the problem down into 3 parts. I'll do 57,000 squared plus 683 squared plus 57,000 times 683 times 2. Add all those numbers together and with any luck arrive at the answer. Now let me recap. Thank you. While I explain something else. I know, that you can use, right? Forget everything else. While I do these calculations, you might hear certain words, as opposed to numbers, creep into the calculation. Let me explain what that is. This is a phonetic code, a mnemonic device that I use that allows me to convert numbers into words. I store them as words and later on retrieve them as numbers. I know it sounds complicated. It's not. I just don't want you to think you're seeing something out of Rain Man here. There's definitely a method to my madness. Definitely. Sorry. If you want to talk to me about ADHD afterwards, you can talk to me. All right. By the way, one last instruction. For my judges with the calculators, okay, you know who you are. There is at least a 50% chance that I will make a mistake here. If I do, don't tell me what the mistake is. Just say you're close or something like that, and I'll try and figure out the answer, which could be pretty entertaining in itself. If, however, I am right, whatever you do, don't keep it to yourself, okay? Make sure everybody knows that I got the answer right, because this is my big finish, okay? So, without any more stalling, here we go. I'll start the problem in the middle with 57 times 683. Now, 57 times 68 is 3,400 plus 476 is 3876. That's 38,760 plus 171. 38,760 plus 170 is 38,931. 38,931, double that to get 77,862. 77,862 becomes cookie fission. Cookie fission is 77,822. That seems right. I'll go on. Cookie fission. Okay, next I do 57 squared, which is 3,249. So I can say 3 billion. Take the 249, add that to cookie. 249, oops, but I see a carry coming. 249, add that to cookie. 250 plus 77 is 327 million. Fission. Okay, finally, we do 683 squared. That's 700 times 666 plus 17 squared is 466,489. Rev up if I need it. Rev up, take the 466, add that to fission to get, 328,489. Good. Thank you very much. I hope you enjoyed mathematics. Thank you.